welcome back. Section 1.8 is on rate of change. So, what does that mean, rate of change? Rate of change is the rate at which one variable changes compared to another variable. So, for example, if you were looking at, let's say, speed or velocity, basically when you measure someone's speed on a bike, in a car, whatever, usually we talk about kilometers per hour. We already talked before, this is a rate because you have two different units, right? Now, as one thing changes, as the number of hours, for example, change, the number of kilometers someone traveled would also increase. So if I'm going 60 kilometers an hour and I travel for 1 hour, I've gone 60 kilometers. If I travel for 5 hours, I've gone 300 kilometers. Right? 60 times 5 is 300. So basically a rate of change is just looking as one thing changes, in this case time, how much does another thing change, in this case distance. Okay, it actually turns out that rate of change is going to be equivalent to slope. When you find the slope in on a graph, in some kind of function, if you have an equation, when you find the slope, you've also found the rate of change. Okay, so it's when one variable is compared to another, and these two variables that you compare to each other, one's called independent and one's called dependent. So let's try to define this. I actually find this tricky. Sometimes it's not totally clear which one's which. So an independent variable is a variable whose value can be freely chosen and which is not dependent on any other value. So if we go back to our velocity thing, we have time for hours, and we have distance for kilometers. Now, which one of those is not dependent on anything else? I know it's kind of confusing, but that would be the hours, right? How long you drive the car, that is up to you. You can drive it as long as you want, as long as you want. The one that's dependent, so let's go down to dependent. Dependent is a variable whose value relies on the value of another variable. That would be your kilometers, the distance, because the distance relies on how long did you drive for. If you drove a short distance, if you drove a short time, you didn't go very far. If you drove a really long time, you went further. So hours, time, is independent because you get to choose how long you drive the car. Distance is dependent because how long you drove the car is going to impact how far you drove the car. I know it's not totally clear. I've never found it totally clear myself, but anyway, if you are able to, and hopefully you are, figure out independent and dependent, if you're going to graph them, the independent goes on the horizontal or the x-axis, like down here, and the dependent goes on the y-axis, the vertical axis. So like this one right here. Okay. So here's a graph. It's got a slope. It's a rate of change. What's the independent variable? What's the dependent variable? Now, one way to do this is just look at this last bit I just told you. Independence on the x-axis and dependence on the y-axis. Well, the one that's on the x-axis is time, so that must be, since it's on the x-axis, it must be independent. And in fact, it is. This is time for independent. And what do we got here? The candle length is dependent. So I guess I should talk about what are we actually seeing here. I haven't even talked about what this graph is about. Basically, what you're looking at is, I guess you light a candle, and we're taking a look at how long is the candle after a certain amount of time. And as the candle burns, the candle gets shorter and shorter, right? As the wax melts, it gets shorter and shorter. So there you go. Independence time, dependent is candle length. So let's just see if that makes sense. The time, does that make sense? It's independent? Yeah, it kind of does, right? Because you could light the candle for 10 minutes, 5 minutes, no minutes. You could not light it at all. But candle length is dependent. What's it dependent on? The length of the candle is dependent on how long did you have the candle lit. So candle length depends on time. Independent, dependent. All right, next thing, calculate the slope. So you're going to find slope the same way we've always done it. you're going to do rise over run. Since we have a graph, remember if you have a graph, what you're going to do to find the slope is you're going to do rise over run. You can use any 2 points you want on the graph. Look there's pretty points all over the place. This is a pretty point, this is a pretty point, this is a pretty point, this is pretty. But what the heck, since they gave us the 2 dots right here, why not? I'll use those 2 dots. So we've got this and this. Now watch, you got to be really careful here. How much is this amount right here? 1, 2, 3. Our rise is 3. How much is this amount right here? I know what a lot of you are saying. You're saying 1, 2, 3. 3. Wrong. Why? Why is that wrong? Why is that not 3? Because look, on this axis it goes up 1, 2, 3, 4, 5, 6. That's what we've been doing up until now. But look on this axis. It goes something 20, something 40, something 60, something 80. Oh, what must this must be 10, 20, 30, 40, 50, 60, 70, etc. It's going up by 10. So in fact, it's going from 0 up to 30. So it's 30 here. Or if you want, we said it's going up by 10 every time. So it's not 1, 2, 3, it's 10, 20, 30. This is 30 right there. Ooh, you got to be careful about that. Watch the scale. If it doesn't go up by 1, you're going to have to be a little bit more careful about it. So calculate the slope. The slope is rise over run. So it's not 3 over 3, it's 3 over 30. Hey, we could put that in lowest terms. You could divide them both by 3. You get 1 over 10. That's the slope. Now, what's the rate of change? Well, the rate of change is just equal to the slope. So the rate of change is 1 over 10. But 1 over 10 what? Like you want to get some units in here. Well, it's 1 over 10 inches per minute. It's always going to be this one over that one. It's going to be dependent over independent. So we've got inches per minute. 1/10 of an inch per minute. Or if you like decimals, that's the same as 0.1 inches per minute. But wait a minute. There's one other thing that I forgot. Oh my gosh, I can't believe I forgot this. Way back here when I calculated the slope, do you see what I forgot? Look at that line. That line is decreasing. So if you want, this would actually be -3 because we went down. Or if you don't like to do that, which I don't really like to do, I like just to say that my slope is negative. This was a negative slope, -1/10. So actually the rate of change is -1/10. Or negative 0.1 inches per minute. That makes sense because the candle's decreasing. The candle's getting smaller. So that's what the negative represents there. Okay? So slope and rate of change, they're just always going to be equal to each other. One last question, although it's got a lot of parts to it. Willard, it's a great name. Willard works as an electrician's assistant and he earns $15 an hour. What's the independent variable? What's the dependent variable? Well, I guess their rate is right here, isn't it? $15 an hour. So what do we got? Hour is time. And the $15 an hour, that's like his earnings. How much he earns. Money earned, if you want. So which one's independent? Which one can you do, you can choose. You can't choose how much money you get. It's 15 bucks an hour. That's not independent. You can choose how much you work, I suppose. Not totally, otherwise you might get fired. But time is independent. In fact, I'll tell you right now, when you have time, which you will have a lot in these questions, it's always going to be independent. Dependent is your earnings, because your amount of money that you earned is going to depend on how much time you worked. If you worked a little bit, you earned a little. If you worked a lot, you earned a lot. Okay, write an equation that shows the relationship between hours worked and income. So we want an equation that says income is equal to, well, what's it equal to? Income is equal to $15 times the number of hours you worked. So 15 times, I don't know how many hours you work, so what should I do? Just put a letter. How about H for hours? 15 times H, or just 15H. This equation is a relationship between how many hours you worked and the amount of income you get. If you work 0 hours, you didn't work at all. 15 times 0, you got no money, right? 15 times 0 is 0. If you worked 1 hour, 15 times 1 is 15. You made 15 bucks. If you work 2 hours, 15 times 2 is 30. You made 30 bucks. If you work 10 hours, 15 times 10 is 150. You made 150 hours, 150 bucks. So this equation shows the relationship. Okay, now we're going to graph it. So remember, independent goes on the x-axis. So we're going to put time down here, and we're going to put earnings or income. How about income? Income here. For our time, let's go up by, we could go up by 1, we could go up by 2. What do you think? Let's go up by 1. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Now, what would be a smart amount to go up by on the income? I would not go 1, 2, 3, 4. I wouldn't go 2, 4, 6, 8. Look at every hour he makes 15 bucks an hour. So why don't you go up by 15? Since that's basically the amount that's going to keep showing up. So 15, another 15 is 30, another 15 is 45, another one's 60, 75, 90, 105, 120, 135, 150. Is that it? No, two more? 165 and 180. Okay, so now let's think about this. If they work no hours, how much money do they make? Oh, we usually put a 0 here too, don't we? If they work 0 hours, I mean, we can use our formula here. We already said this. 15 times 0 is 0. So our first point is, maybe I'll write down, 0, 0. Okay, maybe I'll get some points first. If I worked 1 hour, remember how much money you make? You put 1 in there. 15 times 1 is 15. If I work 2 hours, 15 times 2 is 30. Let's do 2 more. If I work 3 hours, 15 times 3 is 45. And what's the biggest number we have here? 12. If I work 12 hours, 15 times 12, you might need to get a calculator out for that, but it equals 180. So let's graph all those points. We've got the point 0, 0, which is right here. We've got 115. We've got 230. We've got 345. And we've got 12 way over here, and 180, which is the far corner right up there. And what you're going to find for all these relations that we do today, they're all going to be straight lines. So in this case, you end up with a line that goes from corner to corner up there. That's our graph for the relation. Okay, find the slope. Well, you might already know what it is, but if you are confused, we could use our graph right here to figure it out. Pick any 2 points. I'll pick the 2 that are really close together right here. So I'm going to draw my little triangle. I'm going to calculate my rise and run. The run's really easy, right? It goes from 2 to 3. This is going up by 1, so this is just 1. But the rise is a little different. It goes from 30 to 45. Remember, it went up 15 and 15 and 15 and 15. So this amount right here is 15. So how much is the slope? Slope is equal to rise over run, which is 15 over 1. Well, 15 over 1 is just 15. And that's a positive slope, isn't it? So we'll just leave it as 15. Now, that should make sense. How come? Because the rate of change was 15 bucks an hour, right? I should have a question here. What's the rate of change? And the rate of change is $15 per hour. This is your rate of change. And we knew that right in the start, but what the heck? We'll put that down to make it extra clear. All right, E, how much will Willard make in 5 hours? Okay, there's 2 ways you could do this. One way you could do it is you could use the table, the graph. You could say 5 hours. Okay, I go over to 5. I go straight up from 5 until I hit the table. Whoops, sorry. And then I go straight over from there. And what number do I have? 75. So in 5 hours, Willard will make 75 bucks. But there's another way we could do it. We could also use the formula. Remember our formula we came up with, the equation? I equals 15 times H. Let me write that down here. I equals 15H, or 15 times H. Well, this 5 hours, is that I for income, or is that H for hours? Well, come on, it says hours right there. It must go there. So I could actually just plug in right there. 15 times 5, and 15 times 5, no surprise, it's 75. 75 bucks, just like we said there. Okay, last question. If he earned $300 on a job, how many hours did Willard work? $300, not 300 hours, $300. So we have to go up the left-hand side here until we hit 300. Oh, it didn't work out. So what do we do? How are we going to find the answer? Well, you could extend the graph and everything, but that sounds like a lot of work. Why don't we use the formula again? The formula is very useful. I equals 15 times H. So this number right here, this 300, is that income or is that hours? That's income. You got to put the 300 right here. So 300 equals 15 times H. We just got to figure out what goes here and we're done. Oh boy, how are we going to solve this? Well, I don't want to get too into algebra. I'm sure eventually we'll have to talk about it a little bit. But do you remember how to do this? If you want to get the H by itself, you got to get rid of the 15. Since it's 15 times H, we're going to do the opposite. What's the opposite of multiplying? Dividing. Because if I divide 15 by 15, what do you get? 1. You're just left with 1H. That's what we want. We want to know what 1H is equal to. But wait a minute. If we're going to divide this side of the equation by 15, we better divide this side of the equation by 15 as well. So what we're left with, 15 divided by 15 is 1H, or if you want, you could just write H, and that's what we want to know. We want to know how many hours it equal to. And 300 divided by 15 equals 20. So there's your answer. If he earned $300 in a job, how many hours did Willard work? He worked 20 hours. And we are done. Okay, so that's rate of change. Rate of change is exactly the same as the slope. All right, everyone, shorter video today. Hope you enjoy it, and take care.